So question 4 is the first of our ones that have in the format that we can use an integrating factor with. And the way we spot those is that we've got a dy by dx here on its own, and then we've got something here, some function of x here times by y, and then there's some extra function of x over here. So we're not too bothered what's going on over here as long as it's only got x's. This one here is a mixture of x's and y's. And what you're doing there is you're looking for this little bit here. And the integrating factor is e to the integral of this thing dx. So 2x integrates to give x squared. So we're going to times everything by e to the x squared. So we're going to get e to the x squared dy by dx plus e to the x squared times 2xy, and that will equal e to the x squared times by e to the minus x squared. Oh, that was very nice of them, wasn't it? So that side there is just going to e to the 0. That's going to be 1 there. And now we can look at this bit here, and this bit is a product rule. This is e to the x squared multiplied by y. The e to the x squared gives this 2x here when we integrate it. That's why we just did that. The y is just going to the dy by dx. So if you integrate both sides with respect to x, here we lose the derivative. Here the x goes to x plus c, and I suppose we can just tidy that all up if we really wanted to. So we get y equals x plus c all over e to the x squared, or write it all on one line, x e to the minus x squared plus c e to the minus x squared. Part B, what happens as x tends to infinity here? So as x tends to infinity, well, yeah, look, x is tending to infinity here, but e to the minus x squared is going to be tending to 0 at a much, much faster rate here because it's exponential. And so actually the whole thing would be tending towards 0. Y would get closer to 0.